Hello guys, welcome to the sixth lecture of the lecture series of expected question for GATE 2022 Civil Engineering examination. So in this lecture series we will talk about two questions which can be come in GATE examination. So before starting the lecture I will request you, please subscribe this channel because so much of hard work is needed to make this kind of videos. Okay, so I am working hard for you guys, so you just subscribe this channel. Okay, so let's start. So the first question is, the shape of the streamline passing through the origin in the flow field u is equal to cos alpha, v equal to sin alpha for a constant alpha. For a constant alpha determined as, we have to find the shape of the streamline. Okay, now what is meaning of the shape of the streamline? See, shape of streamline is nothing but equation of streamline. Okay, just remember this. When in question they will ask you about shape of streamline, you have to find what is the equation of the streamline. Now here two values is given, one is for u, one is for v. So from this we can understand that it is a 2D streamline flow. Okay, so what is the formula for, or the equation for streamline? We can write dx by u equal to dy by v. Okay, we know this formula from the equation of the streamline. Now we can write v dx equal to u dy. Okay, now we can write v dx minus u dy equal to 0. If we put the value of u and v, it is coming as sin alpha dx minus cos alpha dy equal to 0. Okay, is that clear? Now if we take sin alpha in the opposite side, it is coming as cos alpha dy equals to minus sin alpha dx. Okay, this minus sign is getting cancelling out, so it is coming as dy equal to sin alpha by cos alpha dx, that is tan alpha dx. Now what we have to do, we have to find the equation. That means we have to find y equals to what. Okay, that will represent the equation or the shape of the streamline. Now if we integrate the both side, okay, we have to integrate the both side. Now what we are getting, y equals to, here two terms are present. Okay, tan alpha dx. Okay, so at first it is coming dx, integration of dx is x dot tan alpha. Okay, now in case of integration of tan alpha, see in question it is clearly told that for a constant alpha value. Okay, so alpha is a constant value, like you can consider alpha is 45 degree or alpha is 30 degree. So for constant alpha value, tan alpha value will be constant also. Okay, though the alpha value is constant, so the tan alpha value will also be constant. So we can consider this term as a constant. Okay, now we can write this y equals to x tan alpha plus c, or we can write y equal to x tan alpha. Okay, so from this equation we can get to the answer that the option C is correct. Okay, so in the next question, it has asked, a circular disc of radius r is pushed with a velocity u naught towards an infinite large plate with the gap h between two being occupied by a fluid as shown. Okay, this is a circular plate, okay, and it is pushing with the force of u naught towards this infinite large plate, okay, and the distance between two plate is h is given. Okay, assuming ideal axisymmetric flow about the disk axis, the velocity v at the edge of the disk will be, see, in between the fluid is ideal. Okay, remember the fluid is ideal is given an axisymmetric. Okay, now we have to find what is the velocity at the edge of the disk. Okay, see, due to this push, the fluid will also try to resist this force. Okay, as the fluid is ideal, so it is incompressible also. Okay, it is a property of ideal fluid, it is incompressible. Okay, now how we can calculate the velocity at the edge of the disk? Okay, so for this we have to use equilibrium equation. Okay, this force is coming from the top and this fluid is resisting this force to maintain the incompressible property. Okay, so what we can do, we can use the discharge equilibrium equation. Okay, we can use the discharge equilibrium equation, that means area into velocity of this plate equals to area into velocity of which is generating in this ideal fluid. Okay, which is opposing each and other. Okay, now how we can write the equilibrium equation? Equilibrium equation, and the equation is generating in which direction? Y direction. Okay, we can write area of plate equal to pi r square into velocity is u naught. Okay, and we can also write area of this portion, that is 2 pi r into height h into velocity is v. Okay, from this equilibrium equation we can find what is the value of v. Okay, we can write in this way, v equal to pi r square u naught whole divided by 2 pi r h. Okay, if we cancel out the r, it is coming, and cancelling the pi, it is coming like this, r into mu naught whole divided by 2 into h. Now if we write in this form, we are taking mu naught outside, it is coming mu naught into r by 2h. So which option is correct? U naught into r by 2h, option C is correct. Okay, so thank you for today. If you like this video, please subscribe and wait for the next lecture or next question series which is coming tomorrow. And tomorrow I will upload the next lecture of soil mechanics series. Okay, and very soon I am going to start the fluid mechanics lecture. Okay, within 4 to 5 days I am going to start the fluid mechanics lecture, and maximum time when there is derivation I will teach that derivation on pen and paper, but if there is informative portion, in that informative portion I will provide you in slide. Okay, that means in PowerPoint presentation, and every PPT I will provide you in my Telegram channel, that is arrow civil. Okay, if you are not connected with that channel, please go and join with my channel, where I will provide all the PDF there. Now I am just asking you one thing: if you guys need the solve of GATE 2020 paper or GATE 2021 paper, okay, if you need the detailed solve of 2020 and 2021 paper of civil engineering, I will make video on that. Okay, just comment down below. If you need that video, just comment me down. Okay, thank you.